My time-telling device looks like a drinking bird that many may know is an office or home toy. Drinking birds do not make much noise, but this device may create some from the pen and paper on it. This device will tell time in minutes because it will allow the marking of the paper to be made at a constant rate. Because the paper moves underneath the drinking bird, the marking should be shown in a line. If the device is tracked by minutes, it can be easier to decipher how much time has passed based off the markings. My device uses light to tell time because it can change the rate at which they dip from temperature, such as heat from a light bulb. Heat affects how quickly the liquid in the bottom bulb rises up the neck and causes the head to tip over. My device is an effective way to tell time because the rate it creates a mark on the paper is controlled and constant. It is better than other clocks because it uses a toy that can be found in offices and homes, but never imagined as a device that can tell time. A common problem this solves is modern clocks and time-telling devices are boring. Younger audiences tend to favor the digital clock, and analog clocks can cancel each other out with their similar faces. The drinking bird brings nostalgia for the older audience that is familiar with the toy, and younger audiences can enjoy the strange methods of how the device works. To calculate the volume of my device, I separated my drinking bird into 3 parts, the head, tail, and neck. The radius for my bird is 1 inch, and after using it in the volume equation, the volume was 4.19 inches cubed. The radius for the tail was 2 inches, and after the same process, the volume was 33.51 inches cubed. The neck is a cylinder with a radius of 0.125 inches and a height of 4 inches. After solving for the volume, it equaled to 0.2 inches cubed. By adding up all 3 volumes, the total volume of the device was 37.9 inches cubed. My device uses arcs for its swinging motion from the resting position to the drawing position. The resting position starts at 90 degrees and swings a certain distance to the drawing position. To calculate this, we can use arcs. The formula for arcs is arc angle over 360 degrees is equal to arc length over circumference. The circumference would be the whole circle the device could swing around, but the arc length only gives us a piece of that. By using the middle point of the neck, both sides should have a 2-inch radius, which is used to calculate the circumference. The arc formula should look like 90 degrees over 360 degrees is equal to x over 12.57. After using cross multiplication and solving for x, the arc length 3.14 inches. This means that when the drinking bird swings from resting position to drawing position, it travels a distance of 3.14 inches.